Stupendous. Everyone, thank you so much for joining us tonight on Cyber Judo. Tonight is a very fun and special and interesting cybersecurity session we got for you guys. So Shane Scott, my older brother, and our Chief Technology Officer here at Gotham Security is going to be joining us and going through a little bit about mobile application security testing. At the end of the day, you guys hear all the time about network pen testing. That's kind of like your fundamentals. That's your basics when it comes to, the pen testing domain, right? And then people start to kind of build their skill set into getting more and more advanced and matriculating through into web application pen testing. But where it gets really tricky and where it gets really interesting is mobile apps, because mobile apps have not just a component of themselves being running on different operating systems, running under different CPU architectures, but also there's an element of having to understand how APIs work, because a lot of times mobile applications are not going to conventionally function just like a regular web app. They're usually going to be talking to not just one API backend, but a lot of different API backends. And the first major component to getting started with mobile application security testing and mobile pen testing is essentially the SAST component, right? Security application security testing. So that being said, Shane has his screen shared out here, and we're going to have Shane jump right into it.
Cool. Thanks, man. Yeah, so I haven't done one of these before here. Anyways, I keep things pretty conversational. I don't really follow a tight agenda or anything like that. So essentially, SAST, what we're going to do is we're going to take a look at a piece of software's source code. We're either going to go and decompile it in the case of something like an APK from its Kotlin into Smalley, or even Java and JavaScript. You can do the same with C applications, .NET applications, so on and so forth. But we're just going to go with a nice, simple APK. Main reason for that is that I found the perfect APK to kind of go along with the questionable banking situation going on across the planet right now. So we're going to be taking a look at the Suco Bank mobile application, and that is indeed the name. Now we're just going to be doing SAST. So essentially SAST is, again, looking at the source code, digging through, trying to find questionable operations, hard-coded credentials, dependencies that are suspect, things of that nature. We're not going to really do too much SAST. I will touch a little bit on attaching to a running process and poking at its innards a little bit using something like objection and Frida, so we can actually take a look at some of the, do some class hooking and things like that. But that said, I'm going to primarily focus on just identifying the critical mass problems in this particular application. Now, with that said, like Christian mentioned, we use a bunch of different tools. I'm just going to go over, a handful of tools that I'm going to use tonight. But that said, we use a lot of different tools. It depends upon the language, depends upon the application, depends upon the degree of depth we need to go into. We've got some clients where, the simple processes or the intermediate processes, like what I'm going to show you tonight, don't yield anything meaningful. And we really need to get cracking in there. For example, attaching to class methods and performing overrides or overloading methods, things of that nature. We won't need to do anything like that because this application is just so magnificent. It falls well below the line of what I would consider something acceptable to put on your phone, let alone to keep money with. So again, we're going to look at Suco Bank. This is Suco Bank.
Now, just so we're all on the same page here, as Shane is pulling all this up. So again, this is a process of reverse engineering a mobile application, right? And doing passive analysis on it. So we're not, quote unquote, pen testing anything. We're not trying to exploit anything or anything like that. Yeah. And also, another helpful note is, so as Shane talks about APKs, you have the two most common mobile platforms, iOS and Android. And, with iOS, the applications or binary files are usually IPAs. And with Androids, those are usually APKs. iOS is always, just because it's a walled garden ecosystem, is always a bit more proprietary and challenging to work with. So we're going to, again, focus more on the fundamentals that are a little bit easier with Android.
Yeah, looking at the Android stuff is easier because we can decompile to an intermediate and even reverse into a higher level language versus reading bytecode. So if you want to read bytecode, I can do another one of these and we'll go and step through C and hack some whatnot. But But yeah, like Christian mentioned, we're going to essentially the goals, analyze the code, looking for vulnerabilities, hard-coded credentials, bad practices, essentially any kind of jank shit that somebody might have put in there. Identify any kind of underlying flaws that could make the application vulnerable after it's compiled. Now, for example, maybe you have a string that's being put together in a suspect way, or you've got some insecure deserialization occurring in some places. Those are all things that you can discover during the SAST phase of analysis rather than waiting for it to get to DAST and having either your DAST tool pick it up, or even worse, having somebody else detect it and take advantage of it. Improving the code quality, again, kind of calling out bad practices, bad methods. In some cases, even situations where people over optimized components, and consequently the rest of the code suffers quite badly. And like I mentioned earlier, kind of detecting these things early in the development cycle, so that you're not so you're kind of shrinking the loop in the development cycle. It's better to fail sooner rather than later. Additionally, SAST is a lot more automatable than DAST is. DAST often, especially with a well-written or complex application, automated DAST is it's a thing, but I wouldn't count on it. You're really going to need a human to do that kind of work. So anyways, yes, again, this is Suco Bank. Yes, it's a foreign bank. That said, you should expect some foreign level security expectations. So anyways, I'm gonna go ahead and grab this APK and we'll get started. So I'm gonna go ahead and do a couple things here. So I'm just gonna go ahead and make a directory here called Suco. I'm gonna cd into Suco. I'm also gonna work over here in WSL. I'm gonna, let's see where, you know what I'm gonna do? I'm actually going to, I'm gonna speed this up a little bit. I'm gonna make mnt /suco. And then what I'm gonna do, I'm going to mount TPFS. How big do we'll say 2 gigs. I don't think we need more than that. TPFS Suco. All right. Oops. I must have typed out something here. Oops. There we go. All right. And I'm going to CD into that. Essentially what I just did there is I created a loopback RAM disk, so it'll be nice and fast. I'm gonna go ahead and grab a pre-prepared link to go ahead and download this APK. This APK I'm just grabbing from APK Pure rather than the Play Store. It's inconvenient to do that quickly. It's much easier just to grab it from APK Pure, and I assure you there's not a whole lot of difference in this case. That's not always true though. Like Signal, never use Signal from APK Pure. It's always contaminated 100% of the time.
So that, I think that's actually a good note there. So one of the major differences between iOS and Android mobile app pen testing, and when you start with SAST and grabbing the IPA or APKs, with iOS, there's no iOS stores that host like IPA files. Usually what you have to do is you pull that off of your own iOS device, and then by plugging it into your computer, right? And then essentially shuffling the IPA off through a backup, right? While with Android, because the ecosystem is a bit more open, right? There's all these APK mirroring sites like APK Pure and all that kind of stuff where they'll host applications. One of the things that people should obviously be considerate of that Shane was just noting is that those sites can sometimes have malicious APKs or APKs that have been modified with malicious code in them. So that's why it's never a great idea to install your own APK files outside of the Google Play Store or some other trusted ecosystem, unless you really know what you're doing and you're ready for it.
It's one thing if you're like taking a hash and comparing it against the the production SHA or MD5 or something like that. But yeah, I wouldn't trust that stuff. So anyways, what I've done here, I've used APK tool space D, maybe the APK to go ahead and extract it. And if we do an ls in here, you'll actually see we've got a directory here. With that, I'm actually going to grab a couple of tools here really quick. So I'm going to go ahead and I'm going to grab a copy of, I'm going to get clone, I'm going to get Secret Scanner, which is a tool by me, which is all bash. And Secret Searcher, which is a tool by Dennis that's written in Python. It's essentially a Python version of it that we'll go ahead and use. Additionally, let's see, what else might we use here? We'll start with that. So what we'll do here is we'll just go ahead and start with Secret Scanner and just see what we find.
Cool. So as you're running Secret Scanner here,
Oh, it's already done. That's how fast it is.
wow, wait. So for the folks that are on with us, why don't you tell them just a little bit about Secret Scanner, what it does, what its primary objective is, that kind of stuff.
Sure. Secret Scanner and Secret Searcher are essentially tools that simplify the process of finding common names of methods and variables that often contain hard-coded credentials. That's really all it is. I have to go ahead and do it. Oh boy, we got a lot of results. Few too many. What we're going to do to kind of shore this up, actually, that's it right there. Suco mobile banking. Go ahead and get our list here.
So as you're doing that, so for its edification, so obviously it's a big no-no to hard code any type of credentials or API keys anywhere, but particularly it's quite common in mobile applications because a lot of mobile developers, they have this impression that because it's running on a mobile device that security is less important, and that it's also because it's running on a mobile device in a secure ecosystem running on a user's device controlled by the user. So a lot of times, people might be familiar with the principles of like the OWASP web security, top 10, right? But not necessarily mobile security top 10, right? And one of those major components is embedding API keys and hard-coded credentials that then could be leveraged by a malicious actor against, attacking back-end infrastructure or being able to gain access to somebody's AWS environment.
Yeah, so it's always a bad idea to think that any of those things are inaccessible, no matter how much you've gone and attempted to decipher and hide it. It's really it's a futile effort. So kind of looking through here, I already see something right off the bat here that's alarming. So we've got a class path called constants, which I'm sure there are going to be some fun things in there. So we'll actually go dig through there in just a minute. Here's our main activity. You can actually see where it's actually going. Here's a method for, excuse me, a target for the access token that gets collected after the login, which is the next step, and it's the post step on the main activity. We've got a cache manager. I see a lot of calls to get token, which makes me suspect that this is probably logging all of those things. That would be my guess. Kind of looking through here, looking. Utils, cache manager, yeah, more of that same kind of stuff. App constants. Nothing too interesting there. So what are the things I'm doing here? This is Smiley. So this is the intermediate language that's below Java or Kotlin, but it's not bicompiled. Essentially, what this is a semi-symbolic language that allows us to go through and work with the code at an intermediate level. You can actually modify and recompile this code from this. Now that said, it can be looked at a little bit easier. Let's take a look at something real quick, and we'll do like a quick little comparison. I'm going to just take a look at this constants util Smiley here. I have a sneaking suspicion there are going to be some interesting things in here. So we got some of our cryptography stuff in here, just for the hell of it. Oh, look at that. There's our encryption. Looks like they are doing ASCBC, which is not great, but it's what it is. Let's see here. They're using the secret key spec, this is a Java method to go and actually build cipher classes. Kind of looking through here a little bit more. Do final encode. So yeah, you can actually see the entire process here that they're doing. Now that said, again, this is Smiley, so this is a little bit hard to read. You can actually see right here where they're doing their IV parameter setup, and they're getting it from this byte, which is being read in from what I suspect is going to be the encode constants there. let's take a look at another way to look at this. That's a little bit simpler. So as I don't think I had mentioned it, but there's another tool that can be used called JDAX. I think I have it here.
Cool. Now, so far with your setup's not a complex setup. So you're running like Windows 10 here. You got a WSL, and particularly you're using Ubuntu here, right? And you just pulled those scripts right from GitHub. So we're not even at the steps of having to, set up Android emulators or anything like that. Because again, we're still team just, decompiling those APKs, and we're just analyzing those for secrets and anything interesting. We haven't even gotten to the DAST process.
Exactly. At this stage, we're essentially just we're just digging through and looking for a good place to start. And so I'm going to go to my folder here. I'm going to grab our APK. So what this does, it actually allows us to look at the Java code itself. Now, if you recall here, we were looking at the COM, Suco, mobile banking, constants. There's app constants utils, and I saw a couple others in there of interest. So if we go here, COM, under Suco mobile banking, we got our constants, and here's our utils. So we can actually take a look at those same methods right in here. So we just do a search for AES, and here's our stuff. And you can see this is a whole lot more consumable English-wise. They're actually using the ES as well here. I wonder why that is. Why do they have?
Oh.
There's some suspect shit going on here. But anyways, so just looking at this, you can actually see some things that are really interesting. So we've got a class here called ENC DEC constants, right? .a. A is actually a variable of this. So what this tells me is that this is probably the key that they're using to initialize this, and the IV parameter is B. Let's actually go look for that. There it is. So A, here is their key, and B, here is their initialization vector. On top of that, we've got some other lovely parameters in here. Looks like we can actually just turn off encryption with true falses, which is lovely. Obviously, this would be a good. Yeah, these would be good good things to not do when you're writing software. So obviously, your initialization vector, it should be random, or it should be exchanged in a secure manner, or generated from a secure seed that's been exchanged. Public keys are okay to have, but it's better to not have them hard coded like this. And keys themselves, this is always a no-no. These should be exchanged in a secure manner. Three-way handshakes, things like that. But this is just not advisable. So yeah, that's right there. There's something right off the top. Now, with that said, having these parameters, it actually wouldn't be too difficult for an attacker to go and recreate the method that is going and performing the validation for the login. We actually just look through here. Oh my goodness, I just found something else a little bit alarming. So just hunting around randomly here, thinking that this might be the target for the target method for processing the account, essentially processing the login. We see some other super suspect operations going on here. We gotta try a catch. Interestingly, it just goes ahead and takes the JSON exception E and sticks it in the stack trace. So this means that whatever is in this array, including this JSON payload, is going to be in the stack trace, which means you could actually just go and enable debugging on this APK, stick it in the Android emulator, set it as a debug application, go ahead and use ADB shell to it, and then you could do a cat log and just trace the log while you're running this. So other things here that's a little bit interesting. So we've got this JSON object, new JSON object, string 3. We've got a lot of just string concatenation going on here. What is going on? This is super bizarre. Super bizarre. So I'm not 100% sure what they're doing here. If I had to guess, they're looking at this is to process particularly a key called payload that's a subkey of result that comes in as the response to the login. Now, with that said, this is not a really ideal way of doing this. It's a little bit hackish, to say the least. Probably what I would do is I'd actually probably create a method that goes and parses this correctly rather than concatenating strings together and digging through them in this manner. So this might be a code quality thing that I might highlight. Let's keep digging. Let's see what else we can find. I'm gonna go ahead and just minimize this. You know what? I can't minimize it. I'm gonna close it. That way I can get my console back here. So when you're working with APKs, the same is true actually when you're working with the iOS IPAs. Looking at the SSL Trust manager is usually a good idea. That's usually where you can start figuring out, you know, if there's key pinning, if there's not key pinning, is there key validation. In other cases, there might be they might have certain validators set up to ensure that even if there is no pinning going on, that the certificate chain is is trusted by a third party and not necessarily trusted by the local root store. Or in some cases, you might find that it has no trust at all. One of the ways you can do for that is just kind of looking for a handful of specific keys. So I'm going to go back to, I'm going to go and look at that results file that I created earlier using Secret Scanner. I'm just going to look for SSL in here. So here's an SSL context from OKHTTP. Now, I'm not sure how much you all are familiar with OKHTTP. OKHTTP3 is it's a plugin that people use as a wrapper for the for basically all SSL, or excuse me, for all HTTPS connections. And you can also use it for WebSockets as well. But generally speaking, people will use this specifically for implementing key pinning. So we've actually got some calls here to key pinning, but you'll note that actually these are the library themselves. So what we'd want to do is actually just look for other calls to the pinner itself. But we'll do that here in just a moment. I'm interested in something a little bit lower than that. I get the impression they probably haven't bothered to do that much. So let's see here. Here's our SSL context from this library. I'm not familiar with this library. I'm not sure what it is. SSL context builder, HTTP client, context builder. Let's go take a look at this. Let's see what's in here. See if there's anything interesting. All right, so, and I apologize, I know I read quickly. So here's actually our trust manager. Interesting. So it catches when there's no such algorithm or a key management exception. That's interesting. So with that said, one example of a way that you might circumvent this kind of thing, if you're performing DAST, would be to either remove these lines entirely. That way, no exception is ever raised. Or you could actually just flip the value of the output so that, you know, if it's returning false under the conditions it needs to return true, you just essentially invert it. That way it returns the value that you want under the undesirable circumstances versus the desirable ones. So you're able to kind of continue doing what you want to do. I'm going to kind of
as a quick note to that as well, sometimes you have to watch out. So if you are bypassing, say, certificate pinning or any such setup, you can't just return void in some instances, because what may happen is if the code is set up to say that it expects for instance, if it expects a SSL pinning error to be raised in the event that the certificate is incorrect, and you simply return void, when you recompile that into an APK, it will not work. It will absolutely crash the application. So you have to handle it in such a way. Now, if you have if-else statements, if you flip an if-else statement to where it returns early, but you know, or it's always a condition that will succeed where it will always return, that is fine, because you're having the possibility, even if it never reaches that conclusion, you're having a possibility of it continuing on and raising that SSL pinning exception. But you just want to make sure you don't get in a situation where you can't do it, because otherwise the application just won't work. It'll just crash whenever you load it up. So.
exactly.
Quick clarification note for folks here. So if I may, so Shane, Dennis, you guys are gurus when it comes to, mobile application security testing compared to myself. But when you guys talk about recompiling this intermediate language Somali back into an
Not
APK.
Somali, it's Somali.
Oh,
Somalia is a country.
no, my apologies. So that being said, so when you recompile it, what are the tools that you're usually using? In the past, I used usually it was the standard APK tool, but do you guys use any other tools to recompile it?
Yep, just a mixture of APK tool, the APK signer, as well as you need to use zipline. And depending upon what version of the tools you have, there's some fuckery to make sure that a certain resources file is not compressed, despite it being in a compressed file. So it's important to use the more recent versions. But in that last class file I was looking at, I saw a reference to the SSL socket factory. Now, what I did, I just jumped in here and I'm looking, and here's that SSL socket factory. I'm going to take a look at this file. This is where I suspect they're actually building their connections. Let's take a look in here, because this is where I would expect to see their validation. So let's see. Let's go ahead and so we have a bunch of different constructors here. Let's see what they're actually building, though. I apologize. I realize this is a lot of me reading very quickly.
No worries. So just for everyone's context here. So Dennis, you came primarily when you joined our firm from a web app pen testing background, and you've had the opportunity of building up your skill set when it comes to mobile application security testing. If there was 3 tips you were going to give to anyone who's a web pen tester, tips to help them get started with mobile application security testing, what would those be?
It would probably be so depending on how you look at it, it might seem overwhelming. It's not too terrible bad to get into. Transitioning from web to mobile is not as difficult as you may anticipate. As far as tips go, I think that would be probably the first one. Second one, I think one thing to remember, if you're not familiar with the Android operating system in general, it's basically just Linux, right? It's a glorified Linux kernel. A lot of what you could, traditionally do on Linux, you can do as long as you have either root or ADB enabled. So it's don't overcomplicate it, right? I guess that's my biggest tip I would give. Don't think, oh, it's Android, there's so much to it. It's not nearly as complex as it is. If you have a good tool, Shane is very familiar with Smalley, obviously. He's been digging through the source code for a long time now. But if you're getting into it, my recommendation would be to approach it with something like JDAX. So I think there was he had demoed it at the start of this. JDX is a great tool because it produces Java code. Java code is much easier to read comparatively to Smalley. Now, if you're making modifications, you're probably going to have a better bet doing it in Smalley just because it compiles back easier. But just, take a look at it with JADX. You don't even need to decompile the application. You can drag and drop the APK right into JADX, opens up just fine. And just, keep in mind, it's not nearly as complicated as it looks. If you're familiar with Linux, if you're familiar with web app pen testing, you can transition into this super easy. So.
That being said, actually, so one of the things that I would tend to tell people would be to get familiar with being able to read Java and Kotlin, because that's something that you do less these days in web app pen testing. Not necessarily, it's not necessarily gone, but usually you're not necessarily working at it like from a source code level as much as we do here now with mobile app stuff, because mobile stuff has a lot more like reverse engineering, obviously, right?
Correct. Yeah. So being familiar with just languages in general is a great skill to have when you're going into pen testing. Being familiar with, like Python or C, even if you're not an expert, right? Just getting a basic understanding to get an idea of what you're looking at is a great piece of advice. I think especially if your focus is going to be web applications and mobile applications, I think it's a great recommendation to look into Java, mostly because you have things like war archives that are deployed for older applications that very commonly do have crazy dumb issues and log4j and things of that nature. So you get to have a lot of fun with war applications if you have an understanding of Java, and it also helps you out when you're reverse engineering something like an APK, because of course, APK is an Android compiled down to Somali, which back decompiles into Java. That is, of course, unless they use some weird. This is the corner case exception. But if they use some weird library that's cross-platform, you may run into the code base may essentially be a .so file, so like essentially a Linux DLL, in which case you're going to have to go into a little bit more advanced analysis. But like 90% of the time, you're probably going to run into just plain Java. It's actually very, I would say it's almost a little more rare that we see a cross-platform application. That's not to say they don't exist; they certainly do, but most of the time you're going to run into just something that decompiles back to Java, so no worries in that regard.
Yeah, it's almost universally Java, maybe with some JavaScript in there being served back. That's not to say that you can't have an Android application written in Rust. You can have one written in Python, you can have one written in Golang, you can have it written in C if you want. People just don't do that. But
now, just for everyone's context here, we're mostly speaking about Android right now, and iOS is a bit of a different beast, and that's primarily coded in Swift, which is very C-like. That's hopefully stuff that we'll be able to get together and chat more about in a future Cyber Judo session.
So that SSL socket factory file we were looking at, that class rather, so it kind of defined all of the possibilities that are enabled. What I did is I dug around to look for something that's extending it. And in this case, they're actually building a public class called my SSL socket factory, which feels like it was copy and paste work. But this is actually this is their socket factory that they're actually employing. Now we just scroll down a little bit here. This looks normal. Oh, look at this. Their hostname verifier that they're enabling is allow all hostname, which means they are allowing any cert, bad certs, real certs, no certs, you name it. So this application, despite it being a production application, a production banking application, actually has no TLS requirement at its core. So, for example, you wouldn't actually need objection or FRIDA to go and do any kind of interdiction on this. I suspect you probably could just do it, and it would probably just work. There's a chance that there's some pinning somewhere else, but I doubt it. I doubt it. When you see this kind of stuff, there's a good chance that there's not. Again, interestingly, we've got a situation here where it's actually just taking what's going on and tossing it onto a stack trace. This is a super bad thing to do. You really shouldn't be doing this kind of stuff. Go ahead.
I started to say, out of curiosity, Shane, could you go to the constructor at the top and show off the find usage to see if it's supplying a key store for the MySSL socket? Oh, down a little bit. There you go. Public MySSL. See if you could do a find usage on the function and show that off. And I think you demonstrated that, have you?
No, I didn't. I'm sorry. What is it you want me to search for?
Oh, if you right click MySSL socket factory. There you go. Find usage.
This menu was here.
Oh yeah, there you go. See, yeah. If you so I'll speak on this then. So basically, JADX has this really great feature for navigating. You can actually right click and do find usage, and what it'll do is it will show you the entirety that it detects, at least, of all of the calls that are made to that function. It makes it really easy to trace, what arguments are being supplied, or what calls what, if it's being used at all. In some cases, it may not be accurate, especially if it has trouble decompiling and reconstructing a Java representation. It does not do very well with that. But you can get an idea of what's calling it. And additionally, if you double click on basically anything, even variable names, it will take you to the definition of it. So for instance, like on HTTP host default scheme name, if you double click on default scheme name, it should take you, there you go, to
which is super, super alarming here.
To the definition of it. So anyways, that's just a quick JADX.
Yeah, very cool. So Yeah, I didn't even know about that function. See, I don't generally use this. I usually just work in the Smalley, but that's very cool. Super handy. Thanks for pointing that out. So yeah, some pretty suspect stuff going on here. The let's go back to this fine usage here. To I believe we're here. Yeah. So actually take a look at this. So we're go ahead and we're registering for both HTTPS as well as HTTP, which makes me think, it makes me believe that this is making HTTP calls somewhere. Where that is, we don't know yet. But we do have, if you recall, we found a directory containing the word constants. It's a class path. And we have a whole bunch of things in here. So we already looked at this one. This is obviously their keys and some switches. But let's take a look at some of these others here. So we have, let's take a look at this here. So this looks like maybe it's just like their definitions of text in the UI. Not interesting. App constants. Interesting. So it kind of looks like they have their API poorly documented in here, which is sort of interesting. This could actually make it pretty easy to go through and systematically figure out what the application is doing and recreate some of those things. But that said, you notice these question marks. It's a good indication that the API that backs us is using query parameters. Avoid query parameters at all costs. Really, in the modern day, there's no reason that you shouldn't be using either signed JWTs or JWEs or just encrypted payloads with an exchanged key of some kind. Really, query parameters in clear text is just such a bad idea unless it is truly public information. Let's just kind of look through here and see what other kind of interesting things we see. So we have some default values just to make sure that they're not hard coding anything. That's probably a good thing. This actually may be part of their SAST in-house, where they're just checking to make sure that these values equal something that they expect. So that way someone doesn't accidentally commit the code with a password or something in it. Oh my goodness. They've got an ASP backend. No wonder. Okay.
Ooh, fun. So we got one quick question here. It came from Michael. Hey, Michael, do you want to unmute and throw your question out there?
Yeah, sure. For Shane and Dennis or anybody else that is familiar with mobile applications like this, the tool you're using right now, Shane, seems a little familiar with like Burp Suite site mapping almost. What I'm familiar with web app background. Is this kind of theoretically the same thing that you're doing? And would you use Burp Suite on a test like this, like by injecting the CA certificate into the mobile application, like with Frida or another tool?
So that's a good question. So the SAST portion of it is us essentially going through and figuring out, where the weaknesses are and if there's any kind of credentials in there. The idea there is that we can then take that information and either apply it towards DAST. So we can essentially take that information that we've learned. So we have more of a white box approach to our DAST instead of just purely black box. So we can systematically go and hit certain things, knowing what types they expect or how they might be formatted. And on top of that, we can also then take advantage of any credentials. But with that said, an application like this one, I don't even think we would need to use something like Frida or objection. I suspect no certificate pinning is actually going on. I suspect it would be possible just to interdict the data right off the bat. But with that said, the vast majority of applications are going to have some kind of key pinning. And even if they don't have key pinning, if they have not set the allow all host verifier, what's going to happen is that the default SSL trust manager that's part of the Android SSL connection factory, SSL socket factory rather, is going to prevent users from navigating to certificates that aren't tied eventually to the certificate trust, the local trust store. So with that said, but the majority of the time, you're going to need to inject a certificate either using like Magisk or editing the image itself and sticking it in there. But in this case, that's not quite necessary. In other cases, it's also possible to go ahead and modify the certificate pinning. We have one client who shall remain unnamed that they actually don't do. It's technically key pinning, but in the sense where they're comparing the hash of the incoming key versus the key that they expect. And if those differ, then essentially there's a problem. In a case like that, you could actually just go in and generate your own key, get the hash, or whatever hash value, whatever hash it expects. If it expects a SHA-1 or a SHA-256, and just modify the code. You could either do it again in JEDEX or you can do it in Smalley, modifying the code to go and alter the value that it anticipates. That way, when it goes, it hits your endpoint serving your certificate, it passes validation. However, when it hits theirs, it will fail. But that doesn't matter because you're proxying it anyways, and the purpose is to be able to look at their traffic.
Yeah, to Shane's point as well, Magisk, personally, Magisk is my recommended option, only because it persists past updates much easier. So for those of you who don't know, you can essentially build a Magisk module. It's not even a built module. What it is it's a basically you create a directory tree specifying, the path to Android's root certificate store, and then you just add in your own root certificate that you're expecting for burp. And if the device is rooted, with Magisk, as soon as it turns off, turns back on, before the device is fully set up, it'll inject that certificate into the path for you. So you don't really have to do basically any modification of the image. You can run any OS image that you really want. And as long as it has Magisk and root, it should be functional for your interception. That a note to say though, is that some applications, such as in the latest versions of Android, we encountered this recently, Chrome actually has certificate transparency. So what that means is it will validate your certificate. There are ways to turn it off. Again, with Magisk, you can go in. I haven't tried this yet. I need to mess with some, but you can actually go in and modify or create a module that injects startup arguments to Chrome for Android that should disable that. It's a little finicky, but again, like I said, for some applications, it's a problem, but for most, you're probably not going to run into certificate pinning issues, or not certificate pinning, but certificate transparency issues rather.
What that actually does, those startup arguments, it's possible to do the same thing if you were to go and patch Chrome with Frida using like something like objection. Then what you could do, you could list the activities and find the activity that manages that particular method, and then you could do you could watch it to see what the values are. It's probably just a true false, and then go ahead and do a set return value just to overload it all the time. That way, you just kind of bypass it that way too.
Awesome, guys. Thank you.
As we kind of look here, look at this. This is super suspect. This has got jank written all over it. So this string is called upload check details. So this application, we know that it's a banking application, so perhaps it can scan in checks. So upload check details. This is an HTTP endpoint. So as we saw earlier, we suspected that this uses HTTP. There's actually a hard-coded path here with an IP. So this would be great for continued exploration to figure out, what the external attack surface looks like for the rest of the API that backs it, so the rest of the infrastructure that backs it. But on top of that, kind of digging and seeing what kind of authentication is required on this. This is a banking application, so I'm not going to dig too much, even though it's a foreign one. But that said, just kind of thinking about the things that we've seen here so far, just kind of looking through this, we've seen, number one, so first of all, they're allowing HTTP. So that's a super bad practice. They have hard-coded credentials, hard-coded paths. They have IP addresses exposed in here instead of host names. Super bad practices. We've got hard-coded keys. Not a good practice. Public key is one thing, even though it's not ideal. It's better to use something like GCM. But doing AES CBC is also not a great practice either, because you can end up with blocks which are in clear text. It's not super common, but probably shouldn't be using that nowadays as well. And then what else? Initialization factors, hard-coded. That means every single person using this has the same initialization factor for their key generation. Not a good practice. It can result in the potential for collisions, but it also makes it a whole lot easier to crack that key. Now, obviously, we could continue to dig in here. If I had to guess, we've got to get OTP and confirm OTP. I wouldn't be surprised if it's possible to actually go and, like send OTPs with, with altered text. It just would not surprise me given the way this works.
Now, one of the things that everyone should be aware of, what Shane just pointed out with that server
endpoint for uploading checks, right? So you can have your mobile application, the details within it expose back-end underlying infrastructure, both from an application level as well as a network infrastructure level, right? We can see that that's a singular IP. There's obviously not much redundancy on that, sort of that kind of stuff. That is now a prime target for a malicious actor, right? Because they know what type of information is being stored there. They also know that there's the opportunity for performing man-in-the-middle attacks, right? Between whoever is using this mobile app, right? And that network endpoint, right? Same thing if we see other API endpoints that specify hard-coded API credentials. We've even seen in certain situations where a client could have a mobile app, they would specify an AWS API key, and that AWS API key that's hard-coded in their mobile app like allows us access to their entire AWS environment to start provisioning resources, getting access to S3 buckets and sifting through confidential data, all types of stuff. Quick pro tip for anybody who's trying to look to like take their pen testing game, even if it's regular network pen testing, up a level, which is when in your process of doing reconnaissance and open source intelligence gathering, look to see if the organization you're doing pen testing for has a mobile app that's on their site or that's hosted or something like that. Pull down the APK, you can decompile it real quick. That'll give you more information about the backend network infrastructure associated with that organization that you might be able to leverage. You're not even getting to the hard parts of mobile app pen testing. You're not doing any dynamic analysis. You're not having to recompile the APK or anything like that. But that could make a network pen testing engagement go from blah to wow, this is really interesting. This told us a lot about a lot of vulnerabilities in our underlying cloud infrastructure or network infrastructure where our mobile app is talking back to it.
Yep. So I went ahead and I uploaded this both to MobSF as well as ImmuniWeb. Now, both of these tools, they're great tools for cross-validation. Again, these things are not good for a complete view. You really need to have someone sit down and dig through the code. That said, they're great for cross-validation, just to make sure you didn't miss anything simple. And also they kind of validate your thinking. In this case, like for example, we get possible man-in-the-middle attack. We kind of look through here examples. So ImmuniWeb is great in a lot of ways that it produces a lot of results, and it often errors on the side of false positives. But the consequence of that is that there has a tendency to be a lot of false positives. You can actually see these are both false positives. These are not methods that are being called directly, but actually here is our socket factory that's in use. And so this is the actual problem right here. So it's sort of a false positive, sort of not, but this is definitely a problem. You know, kind of looking through here, there's some other things in mind. Some things to consider would be, you can see examples of some of the hard-coded bits. Some of these are more problematic than others, but there's actually a lot more hard-coded stuff in here than you might think. Looking through that code, poor code quality. Yeah, I have no doubt it won't even load. It's so long. But ImmuniWeb, again, it's good cross validation. But that said, just make sure that you don't rely on it as a comprehensive view of what's going on. Some of the things that we didn't look at, it's got JavaScript enabled in WebView. That's something that is not easy to detect in the code directly. So that's something that's good that ImmuniWeb and MobSF detect. Tap jacking or click jacking protections not present here as well. But then again, those have a tendency to be fairly uncommon attacks. I think we had seen there was some pretty provocative logging going on. And I don't see
so
that.
Mike noted just a moment ago about, did it say clear text SQL table? Believe it or not, you'll see that in a lot of
very common.
mobile apps. Yeah, is they'll have a clear text SQL table for like basic stuff that may not be processing, you know, sensitive information. And so it's a good point to like, just because there is information in here, right, doesn't mean that there's any context behind it. So to Shane's earlier point, like, don't ever trust like tools on their own, especially a singular tool that's especially automated, but they have no context to the types of data that's being processed. Just like there's times where HTTP, like there's times where if it's garbage data, HTTP is fine, right? It's when it's confidential and sensitive information or information which you need to maintain the integrity of, you know? So
One thing I would definitely caution against is these artificial security scores that come from things like Mob SF and ImmuniWeb. And the reason that they take into consideration things which are somewhat arbitrary. Like for example here, we're getting dinged here because it needs to read external storage. The reason why it needs to read storage is because it has check processing capability. So it needs to take a picture, store it on the disk, and then read from that. And somebody might have the application on their SD card. So it's important to watch for those things. But on top of that, you can see things like this. Like for example here, so we've got a, let's go down to the, let's see here.
By the way, so for
Apple
anyone who's not familiar, MobSF is a very popular open source tool for both static and dynamic application security testing of both iOS and Android applications. It's not too bad, but sometimes, Shane, you've noted that it could be kind of a little bit buggy. Think a little bit more with the iOS stuff compared to Android, right?
Correct. Yes. One of the things, and I'm not seeing it in this particular case, but like, for example, let's say that they were using Segment. You would actually see in here a complaint about Segment logging. You'd actually see a complaint about Segment using weak hashing and weak cryptography. Those are situations where, again, your security score is dinged, but 9 times out of 10, those particular findings are sort of false positives because, again, they're contextless. Segment doesn't log anything of importance. It's user experience data, and on top of that, things like its need to go and perform hashing is essentially purposeful for caching purposes. It's not really doing it for like any kind of strong cryptographic needs. Additionally, here's something that we missed just a minute ago. Look at this. Look at this suspect piece of code here. There's actually an NTLM authentication module in here.
It's because it's talking to that ASPX
it's because it's connected to an ASPX.
Using like, oh my God, it's using
which means
IIS.
Correct. That's exactly right. Which means that probably it's subject to directory traversal as well as pass the hat. All kinds of fun things to open up when you're using NTLM.
And the fact that it's running an ASP server, you could potentially, if it's older, you could potentially use view state to be able to bypass authentication, especially because it's using NTLM hashes with potentially an older version of ASP.
Boy, this is just a winner of an application here. But let me show you something of interest here. So if we go down to our, I think it's under reconnaissance here. Yeah, hard-coded secrets. So hard-coded secrets, it almost always finds like the Google API keys and Segment keys and Apple keys and all that other nonsense. Those 9 times out of 10, those are not really a problem. But at the same time, those are the things that Mob SF specifically, as well as ImmuniWeb, will always find. They often won't find other things. Notice the initialization vector and our key are not here. And it simply comes down to the fact that they're not using standard names. So that's one more reason why it's important to go and look at the code directly. And now, mind you, it wasn't hard for us to find. We literally decompiled the application, looked for a file called constants, and then viewed it. So it's quite a lot easier to dig these things out than you might expect. There's so much more to cover, but I know that we're short on time. Anyone have any other questions, thoughts? I don't think I have the chat up.
No, I think what we can do is maybe another 5 more minutes as you wrap up. And then if you want, talk about maybe the next components that can come up in like a part 2 and part 3 of the series, as we wrap up SAST analysis, reverse engineering, and then going into DAST for the future.
Yeah, so I think some of the things that we can do, on our next call would be, digging in deeper into going and attaching some of these activities, attaching to classes, actually performing hooking and poking at the values to see what they do. And the idea there is that there's only so much you can glean from the UI flow in the code directly. It's sometimes easier to actually figure out how the flow works by hooking to a class method on an activity and just changing its value and see what happens. With that in mind, some might say, okay, well, that's definitely DAST. But at the same time, what we're doing, we're essentially performing analysis to figure out, how does it work? Do the workflows here make sense? Is it possible for us to simply attach to an activity and change the value of authenticated to true to bypass authentication entirely? I don't know. We wouldn't know that unless we actually just flipped that value and took a look. and figuring that workflow out might not be so obvious if we didn't do it that way. Moving on from things from that point, Zero Bank looks like an actual banking solution. I'm not familiar with Zero Bank.
Oh no, it's for like security labs, for security lab testing. So
oh, gotcha.
but it looks like a real banking solution. I think it could be interpreted two ways. One, what just happened with SVB and whatnot, right? So Zero Bank, get it? And then two, what we're seeing also here with what's a real banking application.
This is a real bank
being really quirky.
Yeah.
Yeah.
So, you know, besides going and moving into poking at activities and modifying classes, modifying code, maybe next time, so we can, you know, further our understanding from a SAST point of view of how the application works, so we can identify where there are risky methods or risky approaches or problems with the business logic that's handled on the application side. Moving on from that, then we would essentially start getting into DAST, where we would take that information and apply it. So at that point, we would go ahead and we defeat the certificate pinning, whether it be through an automated method, which sometimes would work, not needing any method at all, like in this case, or even going and doing something more manual by, like, for example, going in, extending the SSL socket or SSL socket factory or the SSL trust manager, and just making it so it returns the expected values to continue under all conditions. Because basically at that point, then you can start actually working with the data that you've discovered within the application, not just the credentials, you know, but the strings as they're constructed, looking at decompiling payload or trying to reverse engineer the payloads. In this case, it's not super difficult. You know, we can see exactly what they're doing. They're doing a key exchange. It's AES CBC, and they base 64 it and they pass it back and forth, right? Pretty straightforward, not a great idea, pretty easy to pick out, but in most applications it's not that clear. And a lot of applications, what you'll need to do is actually start with, you know, by going in, defeating that certificate pinning or certificate checking, looking at the payloads through a couple of exchanges and kind of figuring, okay, you know, does this look like a JWT? Does this look like some kind of encryption? And then start kind of working backwards from there, digging in the code until you narrow in on the class and the methods that actually perform the encryption, so that you can then qualify, you know, is this sufficiently secure, or is it insufficiently secure? And I also tell you, you know, you might also see initially in those early DAST operations that, you know, there's an exchange of a common value that is always the same, like an initialization vector. That would be a super bad thing to happen, but we've seen situations where that kind of thing happens. So I would say, you know, again, next one, more advanced SAST, and then we can get into a little bit of DAST and then more advanced DAST.
Super. One last thing that pops in my brain here as we wrap up in the last 2 or 3 minutes is, so I know that personally, when I've had the opportunity of just doing a little bit of SAST analysis, that I've seen even vulnerabilities that are not going to necessarily be listed in tools like MobSF that'll pop out, obviously. Probably the biggest one that I would like to keep in mind is data leakage vulnerabilities. So a lot of times I have seen developers where they're committing information to the debug log of the operating system. And hey, that makes a lot of sense while they're building and working on the application. They're trying to test out, they're trying to figure out, you know, what's going on. They're debugging everything, right? But I've also seen it where they'll forget that the debug flag is left on and they're still logging pretty much everything to the operating system data logger, right? And then what happens is you can have a situation where usernames and passwords, like logins to accounts, right? API keys, session keys, right? Personally identifiable information with social security numbers, bank account details, primary account numbers like PCI DSS data, right? That could all be in the logs of the operating system, of the Android device. And if the Android device has been compromised, it's relatively easy to have a piece of malware just keep scraping the system log, right? And pulling that data and then leveraging that data later on, right? So continue, Shay.
I was going to say, so thinking about that and the call out that you will almost always see for in that clear text SQL database. So it's very, very common for an SQLite database to be used with Android applications. and especially badly written applications will actually store some of these sensitive details in this database. Now, in this case, I don't believe that's the situation. This is actually storing it in a worse place, is actually in a text document, but it's not uncommon for malware to actually look for SQLite databases and and actually extract the contents. Because, again, it's very common for people to use this as a logging mechanism or as a caching mechanism, even though it's really a misuse of an SQL database. And again, you would never really think, okay, is this really what's going on? This could just be a false positive. In a lot of cases, it is a false positive, but at the same time, in particularly poorly written applications, there could be some problematic stuff in there. So it's always a good idea to go and find that database and actually connect to it and perform a basic query to see if there's anything of meaning in there, because there could be.
Okay. So to that, looks like we're just about at time. Shane, any closing statements, anything you want to leave off with?
Yes, don't use Succo Bank.
Perfect takeaway there. So just a reminder to everybody. So downloading an APK, downloading an IPA, decompiling it, reverse engineering it, looking at it, not illegal. Perfectly fine to do. That is not pen testing yet, right? The moment you start to have that recompiled, have your request go back and forth through something like Burp Suite, and you're tampering with that is now pen testing, right? That is now hacking, and that is some serious gray territory. So just remember that you can be like interested in looking at APK and decompiling it, but the moment you start to interface with any calls outbound network wise, that's where you want to stop that. Okay, so keep it legal, folks. That being said, team, thank you so much for your time. Really appreciate it. We'll catch you on the next one next week. Bye now.
Thanks, guys. Take care.
Bye, guys.